You need to heat sand past 1700 degrees Celsius to turn it into glass. Hotter than lava, hotter than a cremation furnace, hot enough to liquefy steel. Ancient humans did not have that heat. Their fires topped out at a fraction of it. And yet, more than 3,500 years ago, someone did it anyway. Somewhere on the sun-baked plain between the Tigris and the Euphrates, someone tending a kiln built for something else entirely watched the ash and sand along the base of the fire begin to change. Not burn, not blacken. Change into something that had never existed on Earth before that moment. Clear, hard, and completely artificial. Nothing in nature makes this on command. And somebody, without any of the tools you would assume were necessary, figured out how to make it on purpose. So how did humans figure out how to turn sand into glass, a material with no natural equivalent, using nothing but fire and ash? The answer starts earlier than the deliberate part of the story because humans had already been finding glass, not making it, for tens of thousands of years before anyone tried on purpose. Obsidian, volcanic glass formed when lava cools too fast for crystals to grow, was being knapped into blades and arrowheads as far back as the Upper Paleolithic, tens of thousands of years ago across Africa, Anatolia, and Mesoamerica. Lightning strikes on sandy ground occasionally fuse silica into branching glass tubes called fulgurites. Meteorite impacts do the same thing on a larger scale, producing sheets of natural glass called tektites. Ancient people encountered all three. They understood, on some level, that heat and sand could combine into something transparent and sharp. What they did not have was any reliable way to reproduce it. Volcanoes and lightning do not take requests. There is a famous origin story for glass, and it comes from the Roman writer Pliny the Elder, writing in the 1st century CE. He describes Phoenician merchants camped on a beach near the Belus River, resting cooking pots on blocks of natron, a natural soda they were transporting as cargo. The heat of their fire, he claims, fused the sand beneath the pots into glass by morning. It is a wonderful story. Most archaeologists today do not believe it happened this way. A driftwood campfire does not come close to the 1700 degrees required to melt silica on its own. But the story survived for 2,000 years because it was trying to answer a real question. And the real answer turned out to be far more deliberate and far more impressive than an accident on a beach. The oldest manufactured glass objects that archaeologists broadly agree on are small beads, found at sites across Mesopotamia and Egypt, dating to roughly 3500 BCE. Assyriologist A. Leo Oppenheim, working from cuneiform tablets recovered from the library of Ashurbanipal, published one of the first major studies of ancient glass-making texts, translating Akkadian recipes that read almost like modern chemistry instructions. Take clean sand, add plant ash, heat until it flows. Those two ingredients, sand and plant ash, are the entire secret. Because pure sand does not melt at any temperature an ancient kiln could reach. It needs help. Silica, the main component of sand, melts at over 1700 degrees Celsius on its own, a temperature nobody had access to until the invention of modern industrial furnaces. But mix silica with the ash of certain plants, ash rich in sodium and potassium carbonate, and something remarkable happens. The ash acts as a flux. It disrupts the way silicon and oxygen atoms want to lock themselves into a rigid crystal lattice, and it lowers the melting point by more than 1,000 degrees. Add a stabilizer, usually lime, to keep the finished material from slowly dissolving back into water over centuries, and you have the three ingredients that make up nearly every piece of glass ever produced, ancient or modern. Silica, flux, stabilizer. Someone worked out that exact ratio using nothing but observation and repetition without knowing a single thing about atomic structure, 4,000 years before anyone had a word for chemistry. By the height of Egypt's New Kingdom, roughly 1500 BCE, glassmaking had become a specialized craft, controlled by royal workshops. Core-formed vessels made by wrapping molten glass around a removable clay core turn up in the tombs of pharaohs. Archaeologist Andrew Shortland at Cranfield University has spent years analyzing the trace elements in these objects, and his work shows that Egypt was not just making glass locally. It was importing raw glass ingots from workshops in the Levant, cooling them into standardized colored blocks, shipping them across the Mediterranean, and finishing them into vessels elsewhere. That is not a village craft. That is an international supply chain for a material invented from sand and ash, running 4,000 years ago. Color mattered as much as the material itself. Cobalt produced a deep blue, prized above almost every other shade. Copper produced turquoise. Manganese produced purple. And for centuries, the recipes for these specific colors were guarded the way a modern company might guard a patent. A cobalt blue glass ingot traveling from the Near East to Egypt was not just raw material. It was closer to a shipment of dyed silk or worked gold, valuable enough to appear as tribute in royal correspondence between kings. Glass, in its first 2,000 years of existence, was not something you used. It was something you displayed. The material stayed a slow, painstaking craft for almost 2,000 years. Glass built one core wound layer at a time, until somewhere in the Syro-Palestinian region, around the middle of the 1st century BCE, an unnamed craftsperson discovered you could dip a hollow tube into molten glass and blow. Glassblowing did not just speed up production. It collapsed the cost of glass by an order of magnitude almost overnight. A material that had decorated royal tombs became something an ordinary Roman household could own. Within a generation, glass windows, glass cups, and glass bottles were showing up in homes across the empire. One unnamed person with a hollow tube changed who was allowed to own transparency. Think about what the full chain of this invention actually required. Someone had to notice a byproduct nobody was looking for, sitting at the base of a fire built for an entirely different purpose. Someone had to isolate which ingredient mattered out of dozens of things burning in that same fire. Someone had to repeat it deliberately, refine the ratio, and pass the recipe on precisely enough that it could survive being carved into clay and read correctly 1,000 years later. That is not luck. That is applied chemistry conducted by people who had no periodic table, no thermometer, and no concept of an atom, working entirely from pattern, memory, and trial. So, how did humans turn sand into glass? The record suggests at least 3 separate breakthroughs, stacked across thousands of years. First, recognizing natural glass, obsidian, fulgurites, tektites, and understanding that fire and silica could combine into something new. Second, discovering the flux, working out that plant ash lowers the melting point of sand far enough for an ordinary kiln to reach it, sometime before 3500 BCE in Mesopotamia and Egypt. Third, industrializing the process, moving from hand-formed royal luxury objects to blown glass that an ordinary household could afford by the 1st century BCE. The English word glass traces back to a Proto-Germanic root connected to glowing and glazing, and further back to an ancient root that simply meant to shine. That same root eventually produced the words gold and yellow. Long before anyone understood chemistry, the language itself already understood that glass belonged to the same family as light. Tonight, somewhere on a shelf, in a window, in your hand right now if you are holding a phone, there is a piece of the exact same material a Mesopotamian craftsperson pulled out of a kiln 3,500 years ago. Sand and ash and heat, and an idea nobody had ever had before. It never stopped being made. It just stopped being rare.